let us start the discussion on the turbine itself. Let us write down the equations of flow of the turbine flow first. One is dA by A by A is equal to capital M square minus 1 to the power dV by V. And other equation likes Fn this is 12. Another thing is dA by A is equal to dP by rho V square, rho V bar, which is it's a vector itself, 1 minus M square, 13 and 17. And dA by A, which is equal to M square minus 1 into capital Dm divided by 1 plus M into 1 plus gamma minus 1 by 2 into M square. Now, if we put just 1 second. হ্যালো না তুমি কি নিচে যাবে এখন দেরি আছে আচ্ছা ঠিক আছে just 1 second. Now if we substitute M, M is equal to 1 in these equations. What we'll find and say as and dA means rate of change of area itself equal to 0 and or A is equal to constant means area is not changing at all. So M occur 1 here, M equal to 1 means speed of the flow is equal to the speed of the velocity, exactly equal to the velocity of the sound and not more than that. It is occurs only on throat. Only on throat itself and nowhere else. And only when this happens only when discharge is the maximum. Now, if the convergent jar act as a nozzle and the divergent pass also, the pressure will fall continuously to get a continuous rise in velocity. And for convergent divergent nozzle, convergent and divergent nozzle, what will happen? It acts as a nozzle. It's only nozzle itself. When the ducts, it acts as a nozzle itself, only because there will be continuous pressure will fall continuously to rise a continuous rise in velocity. Pressure will goes down continuously, and velocity goes up continuously. Now, in other words, say we know the velocity V bar is equal to omega here by rho into A. And for a mass flow rate, where omega mass flow rate, rate, and rho is the density and A is the area. Rho is the density and A is the area. Now, rho is the density and A is the area itself. Now, as the density decreases at a rate faster than the rate at which the area increases, as a result of which velocity continues to increase. Now, what is happening? This density reduces pressure and density with the decrease in pressure and density. Density reduces at a higher rate, faster than the rate at which area increases, as a result of which velocity continues to increases. If density reduces at a rate higher than pressure, then pressure rise, pressure rise, actually the velocity will go on rising itself. And the velocity goes on rising. Velocity is rising itself. Now what happens? It is true that only for a compressible fluid. This is very true for compressible fluid. Say for vapor. Or vapor itself. It is true for compressible fluid and for vapor itself, like vapor. What is that? For incompressible fluid, for a incompressible fluid, the convergent divergent acts as a venturi. For convergent divergent act, divergent that acts as a venturi. Means what happens? Yes, that becomes For the sonic for fluid, the velocity of the track is subsonic before the flow. Here, velocity of the track, velocity of flow, subsonic